Hello, and welcome to another Algebra 2 lesson. This is lesson 6.4. Our objective, graph exponential and logarithmic functions and their transformations. Our essential question, how can you transform the graphs of exponential and logarithmic functions? Well, the same way we transformed everything else. What do we do to f of x to make it go up, to make the function go down on the graph, or left or right? Remember, up or down, we add a number after the f of x. To make it go left or right, we add or subtract a number inside the house for horizontal movement. We multiply for stretches and shrinks. Vertical stretches and shrinks, we multiply out here. Horizontal stretches and shrinks, we multiply inside the house by the reciprocal. So all of those transformation rules we've learned previously will also work for exponential and logarithmic functions. Describe the transformations of f represented by g. All right, take a look. This is just an x squared graph like we've done before, a quadratic parent function. If we multiply it by a negative, what does that do? If we add 3 on the end, what does that do? The negative gives us a reflection in the x-axis. The plus 3 is a translation 3 units up. Did you get it right? I hope so. Okay, try the next one. We have a plus 2 in the house. Remember, x's are tricky. X's always lie to you. Plus 2, we'd like it to go forward, but it's not. It's going to go backwards. So which way is that? That's to the left. Good. And minus 5 on the outside? That's going to go down. And what about the multiplying by 1/2? What does that do? Vertical shrink. There you go. All right. It's okay if you're not writing these down. These are just the fast ones to go through to get us warmed up for the logarithmic and exponential functions. What do you think this one does? Multiplying by the x by a negative 3. Okay, first of all, multiplying by x by a negative. That's a reflection over the y-axis. Okay, so a negative multiplied by the x gives us a reflection over the y-axis. And multiplying x by a number 3, that's technically in the house. It's tucked in with x. In the house is a horizontal. Stretch or shrink, which one? Remember, horizontal, you have to do the reciprocal. So that is a horizontal shrink by 1/3. There it is, reflection y-axis, horizontal shrink by a factor of 1/3. Okay, one more. What does the 4 do? Multiplying. So we started with this. Oh, this is supposed to have an x right here. Two-thirds to the x power. And compare it with this one. So the 4 is new. Multiplying by 4 gives us a vertical stretch by 4 and tucked in the house with x minus 2. What does the minus 2 do? Which way is it going to shift to? It's a translation 2 units to the right. So there it is, translation 2 units right, and a vertical stretch by a factor of 4. Okay, pause here if you need to write those down or just take a look at them. Moving on. Ooh, this is a lot to look at. Little at a time. Here we go. Horizontal translation. X minus h in the house. That's going to go right or left. This applies to exponential functions. It's also going to apply to logarithmic functions. We'll look at those in a moment, in a few minutes later in the lesson. Vertical translation. K. K is the vertical. H is horizontal. H is in the house. So if we add a 5 or have a minus 1 out here, that's going to go up or down. Multiplying x by a negative, it's a reflection over the y-axis. Multiplying the entire function by a negative, whatever you're starting with, is a reflection over the x-axis. Horizontal stretches and shrinks. Notice the reciprocal. This is a 2 times x, and it's a shrink by 1/2. This is an x divided by 2, so that's the same as x times 1/2. So that's a stretch by 2. And then your vertical stretches and shrinks, multiplying out front. Multiply by 3, it's a vertical stretch by 3. So they've got the word vertical way out here. If you were describing this, you would have to put the word vertical with your word shrink. This is a horizontal shrink and stretch. This is a reflection. You would want to put that word reflection with it. So you'd want to carry these words over here. With the up, down, right, left, we don't really need or require this unless you're on big ideas. But we can just say it shifted right, left, up, or down. But these other ones, you have to have that other part of the description, the reflection over the y-axis or the reflection over the x-axis. Okay, so what is a graph of y equals, this parent function they were using was y equals, or f of x equals, 4 to the x power. What does that look like? Here it is. When x is 0, any number to the 0 power is 1. So these exponential functions with x, the variable in the exponent, are going to go through that 0.01. All of them are, because anything to the 0 power is 1. And then from there, shows exponential growth. So if we take some of these things and we put them together, they look a little bit more like this, where if we have a number here, we have a minus h tucked in with the x and a plus k out here. This is where h goes. This is where k goes. This is where a1, I put a subscript 1 on that. That's multiplying. That's a vertical stretch or shrink. If you multiply here, that's a horizontal stretch or shrink. So here it says h is your left or right, k up or down, a1 vertical stretch or shrink. If a1 is negative, it's also a reflection over the x-axis. And then here a2, horizontal stretch or shrink by the reciprocal of whatever this number is. And if that number is negative, then it's a reflection over the y-axis. This is a helpful page to come back to when you're trying to figure out your transformations. All right, let's make some graphs. Describe the transformation of f of x. If we start with 1/2 to the x power, so what changed? We have a -4. So to describe the transformation, it's going to go down 4. So that's a vertical translation down 4 units. That means whatever the y values were for the original f of x, so this is technically the f of x using for y1 and the g of x for y2. We are going to take the y1s and subtract 4. Okay, so let's get some numbers going. 1/2, let's go with a -2, -1, 0, and 1. So 1/2. And we're just going to do this parent function and figure these out, and then we'll subtract 4 to get the new column. So 1/2 to the x power. Well, if x is -2, we have to do the reciprocal to turn that exponent positive, and we get 4. Of course, you can also use a calculator and type in 1/2 to the -2 power, and it'll tell you 4. But it's a good idea to know how to do these by hand as well. And then what about a -1 power? If this is a -1, we flip it over, it becomes 2 to the +1, so that's just 2. 1/2 to the 0 power. Anything to the 0 power is 1. And then 1/2 to the 1 power, well, that's just 1/2. So we can put these on our graph. This is the parent function that we started with, or the starting function. Goes through 0, 1 again. not going to cross that x-axis, so be careful with that. So think about if we went one more number and we did a 2. 1/2 squared would be 1/4. 1/2 cubed would be 1/8, then 1/16, 1/32. It's going to get closer and closer and closer to 0, but it's not going to touch 0. All right, now, if we take those numbers, these y1s, and we just subtract 4. 2 minus 4. 1 minus 4. 1/2 minus 4. And then we can graph it with this column of x's, with this column of y's, and make our graph. -2, 0. -1, -2. 0, -3. And 1, -3.5. So it's going to get really close to that -4. That's our asymptote. Oops. Y equals, here our asymptote was y equals 0, so that shifts down 4, just like the whole graph did. And our new asymptote is y equals -4. Our range, domain and range, let's go in order. Domain is all real numbers, so we can do that fancy R. That means all real numbers, the extra little line. And then the range has to stay above 4, so y is greater than -4. All right, we did domain, range, asymptote. Remember, don't touch the asymptote. And we talked about our transformation, down 4 units. Now, of course, you can use Desmos and make your graphs that way, but you're still going to have to figure out your domain, range, and asymptote. Not all math classes in your future will allow you to use Desmos or even a graphing calculator, so you need to learn both ways. Describe the transformation, represented by e to the x plus 3 plus 2, then graph. So plus 3 is tucked in with x. It's part of the exponent, and then plus 2 is here. So the 3 is going to go which way? It's going to go 3 units left. And what does a plus 2 on the end do? That's going to make it go up. So 2 units up. So what we need is a picture of what this looks like. E to the x. Let's just do our e to the x. So if x is, let's go with, let's just do -2, 0, 1, 2. I should just do -1. We'll start with that. Do you remember what E is? What is E approximately? This comes in handy when we're just estimating for a graph anyway. It's about 2.7. So e to the -1 would be 1 over 2.7. Pretty close to 1/3, but we can get decimal for that. 0.37. And e to the 0, anything to the 0 is 1. E to the 1 power, that would be about 2.7. And then e squared, if we do 2.7 times 2.7, keeping it simple, when we need exact numbers, we'll use the e button on a calculator. That's about 7.29 or 7.3. Okay, so let's graph these. -1.37, -1, and up a little bit. 0, 1, 1, 2.7, and 2 all the way up at 7.3. So 7 and a little more. So I'm going to graph the second function a little differently. Let's just go 3 left and 2 up from the dots we just made. So let's start with this one, the easiest one, 0, 1. 3 left and 2 up. That's there. And then let's do this one, 3 left, 2 up. Okay, it's a little above that line, so go up to above this line, up to above this line. Okay, that's going to be our new asymptote. Next one, here, left 3, 1, 2, 3, up 2, from the middle here to the middle here to the middle here. Make a dot. And then this one, left 3, up 2, and then we can finish our graph. So there's another way, without having to make the extensive table, and I didn't even use a calculator or Desmos. So there you go, exponential functions. This one had a natural base e. Describe the transformation of f represented by g, example 3. Then graph each function. I already have the graphs done. We're not going to focus on the graphs here. I want you to focus on the transformations. Multiplying the x by 3, what does that do? Write it down. Subtracting 5 from x, what does that do? Write it down. So we're actually going to do the minus, there's not parentheses around this, so we're going to state this part first, the minus 5, and then multiplying just x by 3. So we'll do this thing followed by, remember that phrase, followed by. So we'll do this minus 5 first. That's a horizontal transformation, so it's left or right. You decide which way. And then this is by the x, so that's considered in the house. So that's going to be horizontal in the house. Multiplying to stretch or shrink. Horizontal stretches and shrinks, we need reciprocals. So write that down and then come over to this next one. Look at what we're comparing to, e to the negative x. So don't worry about that negative. It was in the starting function. We need 2 things for the negative, multiplying by a negative out front, and multiplying by 1/8. What does that do? Okay. Notice that the function is of the form 3 times 3 to the power of ax minus h, where a equals 3 and h is 5. So the graph of g is a translation 5 units right, followed by, I usually just write FB, followed by a horizontal shrink of 1/3. Okay, 5 units right, followed by a horizontal shrink of 1/3, the reciprocal. Good. Okay, next one. The graph of G is a reflection in the x-axis and a vertical shrink by a factor of 1/8. Did you get that one right? I hope so. All right, moving on. That was example 3. Oh, we can look at the graphs. So there they are. Reflection, remember that's a flip. Reflection over the x-axis. Stretches and shrinks are a little bit tougher to graph, so we would have to either do lots of points or use a graphing calculator to help us. Same thing applies to logs. Minus h in the house is going to be your left or right, but look at how it looks with the logarithm. It's in parentheses, log of, and then compare and contrast that with the vertical translation. Here, notice no parentheses, so this is finding log of x and then adding 3. Up here, this is log of x plus 7, so you would find x plus 7 and then find the logarithm of it. So remember, parentheses changes the order that the operations happen in. So it makes a difference whether it goes left or right, up or down. But it's the same idea, it's just with these new logarithm things we learned yesterday. Horizontal stretch, or shrink. It's going to be inside, still do the reciprocal. Vertical stretch or shrink will be on the outside. And here's a basic graph of y equals a log of x. And if you want to put it all together, here's how it looks with all the variables put in, whoops, and what they do. H is left or right, K is up or down, A1 is vertical stretch or shrink, A sub 2, if it's in here, is your horizontal stretch or shrink, and of course negatives give you reflections, depending on where they are, over the x-axis or y-axis. Another helpful page to come back to. All right, I already have the graphs here. So we're comparing to f of x. Describe the transformation. What does the negative do? What does the 1/2 do? Notice it's tucked in with x. It's part of what we're finding the logarithm of. So it's in the house. In the house. In the house is horizontal. And we have two transformations happening. What does the negative do? Yep, that's a reflection. Over the x-axis or y-axis? It's flipping this way. It's a horizontal movement. It's in the house. So that's flipping over this one, the y-axis. And the 1/2. That is a horizontal. Flip it over. So 1/2, the reciprocal of that would be 2. So that's a horizontal stretch by 2. Or you could say by a factor of 2. We just keep it nice and short. Horizontal stretch by 2. All right, next one. Pay attention to what the starting function is. Log base 1/2 of x. Log base 1/2 of x. So the new numbers are the 4 and the 2. So I don't even want you to really think of these as logarithms. The transformation part is the same as all the other functions we've learned previously. Multiplying out front by a 2, what does that do? Write it down. Adding 4 inside the house, what does that do? Which way does it shift? Write it down. Okay, so back to the 2. That's a vertical stretch. You always want to say by what? By 2. And the 4 plus 4, we'd like it to go 4 forwards, because plus 4 makes sense. You'd think it would go forwards, but it doesn't. Remember, it's an x comparing to an x minus h. So minus a negative. This is going to go left, and you can see it right here on the graph. It went 4 units to the left. So in a test or quiz, if you graphed it on Desmos, you could even look. If you're not sure which way it goes, go, oh, here's the parent function. You graph this one first. And then this one is 4 units to the left. So that is a horizontal translation, 4 units left. We can just say 4 to the left. If you're doing it on big ideas, you're going to have to say that horizontal translation. Translations are slides or shifts. Horizontal translation. 4 units left. All right, and there's example 4, applying transformations to logarithms. Write a transform function. Okay, so we're starting with 2 to the x power. So what do we have to do to our f of x? Think about it in general terms. Let the graph of g be a reflection in the x-axis, followed by a translation 4 units to the right. So don't focus on the 2 to the x yet. focus on, in general, what do we do? Reflection in the x-axis, multiplied by a negative. It's going to go out front, followed by a translation, 4 units right. Right and left is horizontal movement. That's in the house. To the right is a minus. So we're going to have to do a negative in front and then an x minus 4. So we start with 2 of x. We need a negative out front. And then subtract 4 from the x. So that's going to go right here. And that's our rule for G. All right, that's all for now. I'm running out of time. So I will have to make a part 2 video for this one. And you can try example 6. The answer to that is in your textbook. And here is a wonderful summary page that puts lots of things together for the e to the x and the ln to the x. They are reflections of each other, but they all work the same way with the transformations. Exponential functions and log functions are inverse functions. They are a reflection of each other over the diagonal line, y equals x. Exponential functions have horizontal asymptotes. Log functions have vertical asymptotes. And here's a graph of y equals e to the x and y equals ln to the x. On the same graph, notice the reflections across that line, y equals x. Response log. I will understand this better if I watch it again, maybe read the book, or it helped me today when my teacher slowed down. Right now I need to, okay, big ideas assignment 6.4, additional examples on following pages, and in 6.4 part 2 video. I will go back and do example 6 and do the examples that are after this page in video 2. Have a great day. Thanks for watching.